Okay, guys, good evening, everyone. And so just to go through with you guys, we are remaining with 4 topics. We're remaining with 4 topics. And we have to make sure that we finish these topics before the end of, before mock exam. Before mock exam, we have to finish these topics. The topics remaining are vectors, differential equations. Yeah, so differential equations, complex numbers. Yeah, complex numbers. And then we'll go back and do the topic that you actually didn't do, you guys. And that topic, if you remember very well, was series. Some sequences. Series and sequences, yeah. So these are the topics that we are remaining with. And so this is what I'm going to do to make sure that we help one another in preparation of both mock exam and final examination. Even as you go home next week, I'm going to make sure that so I'm going to make sure that even during the holiday, I'll populate your team with all these topics, online classes, and then I'll be able to solve some past papers. So while you are home, enjoying your life and having fun, having good time with parents and friends, going out and doing everything that makes you happy when you are home. In your free times, I'm asking you 1 hour, 2 hours of your day, or just 30 minutes of your day, you go through the classes, and then so that as we open, as we are opening on 3rd or 2nd May, you would have finished the syllabus already. But that's not to say that when you come, that means we are done. No, when you come, we'll start from where we're going to end from in class. So this will just help you go through, prepare, and know these topics in advance, so that as we continue next term, everything will just be flowing because people would have already revised and gone through these things. So please, I'm asking you to cooperate, go through these things in your free times, understand them, try to answer some questions, pick up some past papers, go through and attempt as many questions as possible. Yeah. Okay, so I want to talk about, I'm starting vectors in this class. I won't finish the topic. I'll do 2 classes on this topic. So the first class is this one that I'm making right now. So guys, remember very well from Mechanics 1 last year, from physics, that when we talk about vectors, vectors are nothing but these are just quantities that have both quantities with both magnitude, which is size, and direction. That's what vectors are. That's why we do not have vector by that, okay? Because there's a size which is magnitude there, and there's direction. So we denote vectors by that. And we have a lot of vectors around. Displacement is a vector, velocity, acceleration. Yeah, all these are vectors actually. So we have a lot of vectors around. But see, in this topic, we are not interested in going deep into these vectors and velocity and acceleration and everything that you do in physics. We are not interested in that. We are only interested in doing this in a mathematical way. A vector could be represented by some number or something like that. So that's what we are interested in. And one thing I can tell you before you continue is that this topic is very easy. Just be cool, and be fine with it. Even when you are home, like in the comfort of your time home, you pick up some nice food and anything you're doing, and you watch some video, and yeah, and enjoy. So let's see what we can do here. So one thing I can tell you is that, look, we have three things here. Remember, we deal with this every day. X or Y plane. This is Y and that is X. Okay, we call this is a two-dimension plane. This is two-dimension. So this is two-dimension. Why two-dimension? Because there's only X part and the Y part. And each time you talk of a point here, you denote it with only two numbers. This is 2, this is 3. So you denote it with the two numbers only. Okay, so you are in two-dimensional plane here. So now, so the vectors, so I can denote this by X, and I can denote that by Y. So I can denote that point by X, Y like that. And this side here, under vectors, would denote it by I. This side here would denote it by J. X would denote it by I, Y by J. So that I can write this as XI plus YJ. Because this point is in here, so it's in J, so YJ, sorry, YJ there. That's what we have. But if we are in three-dimension, guys, this is Y, this is X, and this is Y. I mean, this is Z, sorry. So we are in three-dimension, guys. Okay, so any point that we can talk about, we can denote it by three numbers. So if I'm talking of this point here, I can denote it by three numbers. The number for X, the number for Y, and the number for Z, because we are in three dimensions. Okay, this is where sometimes in mathematics, because we're in two dimensions, we'll denote it by R squared. Here, because we're in three dimensions, we'll denote it by R3. Why R? Because we are dealing with real numbers. Okay, we are dealing with real numbers. Here it's R squared because we are dealing with real numbers in two dimensions. Here we are dealing with three numbers. I mean real numbers in a three-dimensional space. Okay, so here now it means this is I, this is J from what I said there. Then would denote this by K. So that this point here, I would write it, for example, XYZ, I would write it as XI plus YJ and then ZK. You see? Yeah, ZK. So we'll denote it by that. So that's one thing that you should know before we continue. So now, the first thing we have to look at is vector notation. How we note vectors here. Vector notation. So if, like I said, we have XY here, okay, this is XI, like I said, and Y what? YJ. Okay. So if this is to say that if I write this, guys, okay, so this means you are talking of A units in X direction, the distance from here to there, A, and then this B, you are talking of B units in the direction of B. So when we denote by that, from here to there, it's A, from there to there, it's 3. So if I have 2, 3 here, what I actually mean is from here to there, it's 2. Then from here to here is from here to there, it's 3, 2 here. So meaning I'm talking of this 2, 3. That's what we are denoting it by that. So this is actually the same. If I write 2, -3, so I'm talking of this is -3, guys. -3 there, okay? And then 2 is, sorry, -3 is in y. So -3 is in, so x. So x there is 2, guys. So this is 2, and this is -3 somewhere there. So I'm talking of this point here, which is 2, -3. Okay, so that's the point I'm talking about. So we denote with that. So we have this direction here going this side. We have that direction going that side. You don't forget that. You always have to denote the direction we are talking about. Okay, so with that said, this is to say, guys, again, that if I write like this, so this is 3 units in the x direction. This is 1 unit, which I'll just denote by J in y direction, and you're subtracting 2 units in x direction. Yeah. And then apart from that, whenever we write like this, when I write like this, okay, when I write like this is a vector. This is, maybe we would denote A like this, 1, 2, 3. So this maybe would be A or B like that, guys. And then maybe B would be this point here, maybe 4, 5, 6. Now remember, we always start from the origin. So if I write like this, I actually mean this. Always the last one minus the first one. The last one, which is B, but this O is there because we always starting from the origin. When I say from the origin, this is always the starting point. Okay, so this is always the starting point. So OB minus OA. So what do I mean by that? So what I mean is, if A is like this, B is like that. So when I write AB, I actually mean, what is B? So the B is what you are calling as, because this B means this is from the origin. B is the same as OB, guys. Don't get confused. Okay, so this would be, what is your B? Your B is actually, so you have 4. You have 4, 5, 6. And then what is your A? Your A is 1, 2, 3. So finally, your AB is 4 minus 1 is 3. 5 minus 2 is 3. 6 minus 3 is 3. So that's what you have there, guys. That's what you have as the answer. So that's one thing that you should know about this. And then apart from that, guys, the other thing that you should know is, sometimes if I give you something that's like this, maybe this is A, this is B, this is C, this is D, okay? And I tell you that, maybe I tell you that the distance from A to B, the distance, okay, is 10 centimeters. Maybe we do this, maybe the directions are this. Those are the directions. The distance from A to B is 10 meters, 10 centimeters. The direction from maybe A to D is 15 centimeters. Yeah. If I put G here and I tell you that AG is equal to half of AB, what does it mean? AG, this AG here is the half of AB. So you're just looking at what is AB. AB is 10. So if it's half 1/2, AB is 10, which means that AG is 5 centimeters. 2 here is 1, 2 there is 5. Okay, so, because sometimes I can tell you that maybe I can put E here, okay, which is here. And I can tell you that E is equal to 1/3 of BD. 1/3 of BD. So the only thing that you pay attention to is finding BD. That's all you do. It's finding BD. The moment you find BD, you just divide by 3. Then apart from that, you also need to pay attention to the direction. If you're moving in this direction, it's 10 centimeters. Remember, when you are going in the opposite direction, it will be negative 10 centimeters because it's in the opposite direction. Because that's about vectors, guys. If you remember very well the concept of resultant forces, if you remember very well, if some of you can remember the concept of resultant forces in mechanics 1, you actually remember that if, for example, I have something of this kind here, right? And then I can do this, which is a resultant force. Maybe this is P, this is Q. I can do this, which is a resultant force of these two things here. And then you develop what? A program. If you remember, you have a program there. But anyway, even if you don't remember, it's fine because we're not going into that far. I'm just emphasizing on certain things that you can remember, some of you, on the concept of forces and resultant forces in particular. So you remember if, for example, I'm moving to this point here, I can either go this way direct, or I can go this way and then I go that way, or I can go this way, or I can go that way. So the direction you choose doesn't matter, but I have to pay attention. If, for example, this was facing this way, meaning if I'm going this way, it will be plus, right? It will be plus. If I'm going that way, it will be negative because the direction itself is showing me that it's going that way. So I'm going in the opposite. So meaning it is negative. So I'm just making yourself get familiarized with certain concepts that you did in mechanics under resultant forces. Okay, so that's about vectors, guys. That's about vectors. There's nothing funny about them because sometimes you could be given your A and then you are told you have this. You see, B is there. So it means you're moving from A to B. That's a direction. And then maybe you're given this point as 1, 3, 4. And this point maybe as 10, 8, 5. You see? And if you want to find AB, I told you, the direction, if you want to find a vector AB, I told you that this is OB minus what? Minus OA. So you're just, in short, you're subtracting A from B. You're subtracting A from B. Okay, so in short, it's the same as B minus A. Okay, yeah, from the basic point of view. That's the same as B minus A. So you're saying 10 minus 1, which is what? 10 minus 1 is 9. 8 minus 3 is what? Is 5. 5 minus 4 is what? Is 1. So that's a vector you have as AB. That's a vector you have as AB. Yeah, so that's about these things, guys. There's nothing confusing about these things. Sometimes, but here, remember, if I was taught to find BA, then I'm saying OA, right, minus OB. Because A is the last one. So I'm saying OA minus OB. That's how I get to find it. So meaning I'm subtracting B from A. So I'm subtracting B from A. That's what it means. Okay, so after talking about that, I can talk about the concept of magnitude or size of a vector. Remember, I've talked of what I'm talking about is about direction. What I'm talking about is about direction of a vector. Here I've talked about, so here I'm talking of the magnitude or size of a vector. And if we have this vector here, the magnitude is denoted by that, the modulus. So the magnitude would be just, if this is a vector which is, let's say it's xy, guys. This vector is xy. The magnitude will be x, you square it, plus y squared. That would be the magnitude. Okay? If I'm representing it in terms of a triangle. Okay, this is your x here, because it's in that direction. This is your y. Yeah, that's what we have. Then we have this, guys, which is a hypotenuse, right? We have this, which is a hypotenuse. So we have that, which is a hypotenuse. So maybe it's in that direction there. This is a hypotenuse. Remember how do we get hypotenuse? If you remember from the Pythagoras theorem. If you remember from the Pythagoras theorem. You just square this and that. Like hypotenuse, if I denote this as hypotenuse, which is P, then P is just x squared plus y squared. It's hypotenuse. So it's basically the same concept. That's a concept of magnitude. Okay? So even if it's a vector in 3 dimensions like that, it's the same concept, guys. The magnitude will be just this. That would be the magnitude. It's just the size of that. That's the magnitude. So that's about the magnitude, guys. Where, let's say, for example, what would be the, let's say you are given 3, 4, 6, and then you are told to find the magnitude. Like I said, it's what? It's 3 squared plus 4 squared plus 6 squared, which is 9 plus 16 plus 36. And you find the answer as the square root of what? The square root of 61, because if you add that, you get 61. So that's a magnitude. That's the length, guys. That's one thing that you need to know. And then apart from that, there's also what we call unity vector. There's also what we call unit vector. So unit vector is if I'm given a vector as A, this is a vector. Maybe I'm given A like that. That's a vector. 2i plus 3j. So the unit vector of this would be A dividing by its magnitude. Dividing by its magnitude. That would be the unit vector. That's what we call the unity vector. Dividing by the magnitude, which would be 2i plus 3j over what? The magnitude of this is 2 squared, right? The magnitude of that is what? 4, 2 squared plus what? Plus 9. That's the magnitude of that, guys. So that's about the concept of the unity vector. Okay, that's the concept of unity vector. Now vectors, we have what? Remember, we have parallel vectors. We have parallel vectors. Now, if vectors are parallel, it just means that they're multiples of each other. What do I mean? So for example, let's say we have 2, 3. Then another vector is 4, 6. So these vectors here are actually parallel because this one here is you just multiply this by 2, you get the other one. So parallel vectors are just multiples of each other. They are multiples of each other. That's what parallel vectors are. They are multiples of each other. So vectors are said to be parallel if they are multiples of each other. One vector is of this length, guys. This vector is of this length here. You've seen this. Yeah. The other vector is So maybe this is A, and this would be 2A. Like you're multiplying it by 2. So that's about vectors, guys. That's about parallel vectors. And then I can also talk about addition. I can also talk about addition and subtraction of vectors. Yeah. Addition and subtraction of vectors, which I actually already talked about. If you remember where we're adding vectors, we just have 2, 3, 4. We are adding 4, 4, 5, 6. We just add them. This we had with that, we get 6. This we had that, we get 8. This we had that, we get what? We get 10. If we are subtracting, it would be 2 minus 4. We get what? We get 2. 3 minus 5. We get what? We get -2. I mean -2 here. 2 minus 4 is -2. 3 minus 5, we get -2. 4 minus 6, we get what? -2. So basically, adding and subtracting vectors is just like that. Okay. The only thing that you also need to know is, like I said, if you're given a diagram, like we have this diagram here, some trapezium, if you look at that. So we have yeah, let's say this is A, this is B, this is C, this is D. So we have, this is in that direction, this is in this direction, this is in this direction, that's in that direction, and then we have this here, which is in that direction there. So first of all, you know that if I want to get SC is the same as what? SC, remember you can either move in this. So for you to get SC, this one here is the same as you go this way and that way, right? So it's the same as AD plus what? Plus DC, right? Yeah. It's the same as AD plus DC. AD plus DC, or is the same as, the same SC is actually the same as, you can either move in this direction, AB down there, and you go up BC. Yeah, it's the same as that, right? It's the same. But you can also, if you're moving in the opposite direction, remember we can also say that SC is equal to what? SC is equal to what? We can move like this, which is in the opposite direction, right? The negative of what? Of BC, right? The negative of BC, and also going in that direction, that's the same as let me just write what I want to write properly somewhere. So in short, what I'm talking about is the making use of the opposite direction. Here we are talking of this distance AC. This distance AC here. If I choose to talk about CA, which is the other way around, which is this direction here, right? It's the same as you can move this, which is in the opposite direction, right? Which is the opposite of DC, and then plus the opposite of AD, right? Which is the opposite of AD. So in short, here you are paying attention to the direction. If it's in that direction there, it's That's the direction you're considering, which is positive. The moment you move in the opposite direction, that's negative. That's what I wanted to emphasize, that you get to know all those things, guys. So we're going to end here for today. And next time we'll actually start from the vector equations. We'll start from the vector equations.